Well, welcome back to another fun night in Common Core Algebra 2. We're going to focus on systems graphically and algebraically. So, of course, graphically implying go grab that calculator and we'll get started. All right, so exercise 1, consider the system of equations below. So first of all, why is it called a system? Well, a system is comprised of one or more equations. So since we have two, we're referring to this as a system. So it says solve the system graphically using the grid to the right. So again, we said we're going to solve algebraically and graphically tonight, so we'll start graphically. And basically all that entails is plotting this graph and plotting this graph. Now it's not just some, hodgepodge, throw some lines up here. We are plotting exact points. So that's where that calculator comes in. We should be plotting this graph in y1 and this graph in y2. So I've taken a few pictures of my calculator. So again, I've plugged one equation in y1, one in y2. Remind yourself here, and you should be putting that in your notes, you are always going to hit zoom 6. That gets you a 10 by 10 window. Okay. And then I'm going to go to the table to actually plot these points. And that's what we need to do. We need to plot exact points. So you'll notice I have my blue points plotted. I'm going to go ahead and connect them. And I'm going to stick an arrow on the end implying that that function goes on forever. And you'll notice I had errors here, so clearly I'm not graphing the function there. So it is starting at -3 and moving on forever. And now you can see I've got my red points plotted, and I'm going to go ahead and connect that, and that is a line, so it goes forever in both directions. So when it says solve this system, anytime you graph more than one function, your goal is to find where these two functions intersect. So I would say the system of this equation is x equals, 1 and y equals 2. Okay, so now you can see that visually from this graph on the table. Notice at 1, 2, it's the same value for both y values. And now you should be able to get this on your calculator. So I want to make a note here in your notebook. On your calculator, you should be hitting second trace and choosing intersect. Okay, now it's nice that they came out to be values that you can see, but when they're ugly numbers, you have to use the calculator to get this. So second trace and choose intersect and hit enter, enter, enter. Now, part B says, solve the system algebraically for x values only. So now let's get a little taste of that. This is great review for our solving systems here. So I've got radical x plus 3 equals x plus 1. Okay, now why did I set them equal? Well, it says y is equal to this function and y equals this function, so basically I can set them equal to each other. All right, so again, great review in solving a radical equation. So step number 1, of course, is to get this radical isolated, which it currently is. Then you can wrap both sides up and square it. Okay, now here the magic happens. The square and the square root undo each other, so I just get x plus 3. But now be smart. On this side, to square a quantity means to multiply it by itself. So that's really x plus 1 times x plus 1. So I get x squared plus 2x plus 1. And I'm going to set that equal to 0. So I've got x squared plus x minus 2. And I'm going to go ahead and solve that. So let's see, that's x plus 2 and x minus 1. If I tee that up, notice I get x equals -2 and x equals 1. Now, one of the biggest problems, and it's kind of up in question C here, it says, what does your answer from part A contradict about what you found in part B? Well, if I look at my graph, they only intersect once, my friends, once. But when I solved algebraically, I got 2 solutions. My oh my, what is going on? Well, here's this big word we need to remember. It's called extraneous. You get an extraneous root if something does not check. Okay, now, they're not going to come out and say, hello everyone, check your answers. That's not how it works. You have to be smart enough to know that when you solve an equation, you have to check. And if it fails, it's called an extraneous root. Okay, so clearly when I solved it graphically, I can see that x equals -2 is an extraneous root, and my only solution is x equals 1. Okay, but that is a lesson in checking, and make sure you don't fall into that. That's one of the biggest missed questions on our exam. Extraneous roots, make sure you check. Example number 2. Find all the solutions to the equation rounding to the nearest hundredth. Well, I want you to underline this nearest hundredth The second they say that, it's probably not going to turn out as a nice equation to do by hand. And look how hideous this is. A cubic, an absolute value. It's just hideous. So the idea is they want you to graph them. Now, they don't have to give you a grid because you have a graphing calculator. But if they give you a grid, then you should obviously plot the exact points. So again, I'm going to pause. I'm going to get this in y1, and I'm going to get this in y2. And you should be doing the same thing. So I've got a few things for you to compare with here. First of all, I've carefully typed my equations in. Now, things that they are testing you on, obviously. Do you know where the absolute value bar is? Okay, so again, we don't want to have this discussion 10 million times in class. Jot it down now. Okay, the absolute value bar can be found in two places. One, you can find it under math, and I believe you have to arrow over to number. Okay, two, anytime you don't know where something is, you can go to the catalog. If you hit second 0, that will take you to the catalog, and everything's in alphabetical order. An absolute value starts with A. It happens to be the first thing in the catalog. Okay, so carefully make sure you know where that is. Obviously, these are just exponents, and that's pretty easy. Now, I hit my zoom 6. Remember, that's my standard window. Not always will things show up, but in this case, they did. And I can see that these graphs intersect once here, so I need to get that point. The other thing you'll notice is I've got my table of values here, and they're pretty ugly numbers, and they're that way for a reason. These weren't very beautiful functions to begin with. All right, so I got lucky where I picked another function where I can actually see the intersection on the table of values here, and it is intersecting at 0, 5. Now, I want to be very clear. Most of the problems in our course are not going to be these nice numbers. So I want you to practice using the calculator. So remember, you're going to hit that second trace, jot the notes down so you know where to find these buttons, intersect, and we want to get that intersection on our calculator. So you can see mine here. Now I want to be clear, you don't actually have intersection until it says it for you. And I can see I intersect at that point 0, 5. All right, now the next one's a little uglier. Find a solution to the following equations. Now again, solving by hand, probably not the prettiest. If they tell you to solve it, you can solve it any way you want, unless it specifically says it has to be done one way or the other. Now, this is where it gets tricky. If you have the updated calculator, that log button is really nice. If you have that old TI-83 or a non-updated one, this is where it can be a pain in the butt. And again, take a few notes to yourself so you remember how to type this in. So again, in my head I'm saying, okay, if two things are equal, that means they're going to intersect. That is the whole key. Look for an intersection. Anytime two functions are equal, it's a lot easier to solve it graphically. So again, if you have the nice updated calculator, you just find that log base button, and it can be found two places. Remember, anything can be found in the catalog. That's on that second 0. Scroll down to the L's till it says log base. The other nice place it can be, again on the updated calculator, is if you hit alpha and the top row, you'll have all the new features. In this case, I think it's alpha window or alpha F2, and you will see log base. You can type in any base you want. So again, I'm putting this in Y1. Now, those of you with that old 83, that little dinosaur of a calculator, this one's kind of annoying. You have to use change of base. Okay, so a quick review if you have the old guy. Jot it down for yourself. The change of base says you put the base on the bottom. So remember, this is called the base. So log 2 goes on the bottom, and this goes on top as log x. Okay, so you have to know how to use the tool that you have. So if you use the old one, make sure you know this. Log x goes on top, base goes on the bottom, and that's how you're typing it in y equals. All right, so again, let's pause it. Let's get this graphed in y1 and y2. So you can see how I've typed it in. I have the updated calculator, so I'm using that log base. I've graphed my two functions on zoom 6, and you'll notice I have my table of values. So it looks like it's intersecting around the number 3, but clearly it's not right at 3 because those numbers in my y values are not the same. So the only way to get this is to use that intersection feature on your calculator. Okay, so again, at second trace, intersect, answer the few questions on the screen, probably enter, enter, enter. You might have to move your cursor a little, but you need that intersection. So now that mine says intersection, whoops, there's a tad bit of a glare there, I apologize. I get at x equals 3 point, and it should tell you what to round to on the exam, 0.1174, and I get a y value of 1.5906. Okay, so be real careful whether it wants just the x value or if it wants the point of intersection. Okay, this time we have to solve both algebraically and graphically, so I'm going to start with algebraically. Now notice this doesn't say y equals, but it does say x equals. So I can substitute this y minus 1 into the letter x. Now if your heart desired, you could solve this equation for y and substitute that into the letter y. Truly doesn't matter. So I'm going to say I start with x squared plus y squared equals 25. And in place of x, I'm going to put the quantity y minus 1, but now I have to square it. Plus y squared equals 25. So I made a substitution into the letter x. Now remember, squaring means to FOIL. So this gets me y squared minus 2y plus 1 plus y squared equals 25. We're just solving a nice system here, so I'll put my like terms together. What is that? 2y squared minus 2y. I'm going to subtract this 25 over. So minus 24 equals 0. Now when I think factoring, remember, always look for your GCF first, see if that'll help. I'm going to pull out a 2. Don't lose it, just pull it out. So I've got y squared minus y minus 12 equals 0. So when I continue to factor, carry that 2 along with you. Let's see, I'm thinking 4 and 3, so y minus 4 and y plus 3. Remember your signs. This is what you add to and this is what you multiply to. So I know my signs have to be different to multiply to a negative. And if I tee that up now, does 2 equals 0 make any sense? Well, of course not, so that gets rejected. Here I get y equals 4 and y equals negative 3. Now I did obviously a step in my head. I hope you can follow me there. Now remember, you're not done because the question didn't say just solve for y. It said find all the solutions. So notice there are x's and y's. You need to make sure you go back and get the x value. And to do that, you simply just plug it into the original. Now here's the beauty. It doesn't matter if you use this original or this original. It really doesn't matter. So I'm going to use the easier one. Y minus 1 equals x. So y minus 1 equals x, and I'm going to plug in a 4. 4 minus 1 equals x, therefore x equals 3. So one solution should be 4 comma 3. And then y minus 1 equals x, negative 3 minus 1 equals x, so x should equal negative 4. So that would be the point negative 4, 3, and hopefully you, oh dear, hopefully you caught that, and that is not correct. The x value is 3 and the y value is 4, so that should be 3 comma 4. The x value is negative 4 and the y value is negative 3. Now, we're going to solve the same equation, but we're going to do it graphically. Okay, so we're going to graph this out on graph paper. Now, the first one was y equals, I'm just going to rewrite it over here, I'm sorry, y minus 1 equals x. So before I can graph something, I do want it to say y equals. So I'm going to say y equals x plus 1. Okay, and I'm going to make a real nice graph of that. So you can see my, oh dear, that did not go through the points. My red line is that y equals x plus 1, and notice my graph goes from end of the grid to the end of the grid. Now, how about this x squared plus y squared? What does this make? You can't type this in your calculator because it doesn't say y equals, and you can't really make it say y equals. Well, I guess you could take the square roots eventually, but we're not going to go there. What is this an equation of? This is an equation of a circle, and it is centered at the origin. So my center is 0, 0, and remember, if this equals 25, remember the formula is x squared plus y squared equals, you've got it, r squared. So r squared is 25, which makes my radius equal to 5. So probably the smartest way to graph that is to start at your center and kind of go out 5 in the main directions, kind of north, east, south, and west. And then to real carefully draw this circle. Now, without a compass, it's really hard to get this intersection point accurate because, just from our nature, we're not perfect, and it's very hard to draw a perfect circle. So that's why solving algebraically comes in a lot handier. But I think we can verify the same intersection points, 3, 4, and -4, 3. And I believe that is what we had over here as well, solving algebraically. Lastly, this system is a 3 by 3. And by golly, we're going to solve this one algebraically, and I think most people were pretty darn good at this, but we'll do one more review before our big exam here. So remember, you can take any two equations and submerge them together to solve the system. So what sticks out to me is there's a positive y here and a negative y, so I'm actually going to start with these two rows. So I'm going to say 4x plus y minus 3z equals -6. Now you certainly didn't have to, but I caught that right away that those are going to cancel. So that's where my gut led me to. So if I add, then those disappear, and that gets me 9x minus 10z equals -25. Okay, now I have to pick a different set, but I still have to eliminate the y's, remember. So at this point, it really doesn't matter. I think now maybe I'll just grab the first two. So I'm going to say 4x plus y minus 3z equals -6, and -2x plus 4y plus 2z equals 38. Okay, so now remember, my goal is to eliminate the y's. So I need to see the same coefficient but different by a negative. So I think I can just multiply this first row by -4. So that would get me -16x minus 4y plus 12z equals 24. And I'm going to keep the second row as is. Basically, it's like multiplying by a +1. And I'm going to add those together. Now remember, I just had to make sure I eliminated the same variable, which I did. So I've got -18x plus 14z equals, what is that, 62? And now I'm going to put those two equations together. So my 9x minus 10z, and I'm going to solve a 2 by 2 now. Okay, so the numbers could get big. It really doesn't matter. The goal is you need to have the same number. So one quick method is just to multiply by the opposite. You could multiply this top row by -18, or 18, and this row by 9. But I know 9 times 2 would get me 18, so I'm just going to multiply this top row by 2. So that's going to get me 18x minus 20z equals -50. And then I have multiply basically the bottom by 1 plus 14z equals 62. And if I add those together, let's see, that'll cancel that out. And I should get a -6z equals 12. Therefore, z equals -2. Now, once I have one variable, I just have to go back and get the other two. So I'm going to pick an equation that only has 2 variables in it. Perhaps this one here, -18x plus 14. I just found out my z is -2 equals 62. So -18x minus 28 equals 62. -18x equals, is that 90? Therefore, x equals -5. And now that I have x and z, I'll plug it into an equation that has all 3, perhaps this first one. So 4 times -5 plus y minus 3 times -2 equals -6. So that's -20 plus y plus 6 equals -6. So that's -14 plus y equals -6. Add that 14 over, and I get y equals 8. So now we've officially solved that 3 by 3. And what does that mean? Well, that means when x is -5, y is 8, and z is -2, in this equation I should get -6. In this equation I should get 38, and in this equation -19. Well, that has it for our review on systems graphically and algebraically, and we look forward to some great practice.